So number 6, I'll move this up here. We're asked to find the velocity of the light in different media, right? So first one is water, next one is crown glass, and the last one is diamond. And in the book, we're actually given the index, right? The index of refraction. And we can use that in this formula and just solve for V, right? So part A, V in water is going to be 3 times 10 to the 8 meters per second. C over the index of refraction of water is about 1, but not exactly 1. Part B, we end up, I'll write the answers down here in a second. Part B, we end up going C over, it's 1.52 for crown glass. And then C, it's going to be speed of light over 2.419 for diamond. And so if we plug these into a calculator, I'll actually leave that up to you. These are pretty, I mean, this is super straightforward. So all you got to do is plug 3 times 10 to the 8 meters per second in over the index of refraction, and it'll give you your velocity, right? Next problem, number 19. We're told that a beam of light is traveling in air. It meets some oil, is refracted at 20 degrees from the vertical, and then it refracts again once it hits water with an unknown angle from the vertical. So we want to know at what angle is it entering into the oil, angle of incidence, and then we want to know what is the refraction angle in the H2O. So this is not too bad, but we're going to have to apply Snell's law a couple of different times. So what is Snell? What's his deal? What's he saying? Snell says N1 sine theta 1 is equal to N2 sine theta 2. So we know the index of refraction for air is 1. Right? We know that. Also, I mean, if we just move the vertical or the normal over here, like let's say we move this over here, then we'll get your standard setup is like this theta is going to be 20 degrees, just like this one. So these angles are the same. That's what I'm saying. If I can just show it, here we go. This is also 20 degrees. Okay, so we're going to plug this in. What we want is this angle of incidence. So that's going to be, let's call this air, right? N air sine theta air. Or we'll say this is the angle of incidence is equal to N2, which is N of the oil, times sine of 20 degrees. Okay, so then we take angle of incidence is equal to N of oil, which is 1.48. I think we were given this in the problem, or I looked it up. Either way, that's what we got. Move this over here a little bit. This is going to be the arc sine of this. So all I'm doing is taking this formula and solving for this angle here, or this angle here, okay? And that's sine of 20 degrees. So when we plug that in to a calculator, this gives us an angle of incidence of 30.4 degrees. So this angle is 30.4. All right, moving on to the next one. We do the same thing. We apply the same formula. N oil sine 20 degrees is equal to N of water, H2O, sine of some unknown angle, right? We'll call this theta 2. In the diagram, it's called theta prime, so we'll keep it theta prime. Okay, and then we solve for theta prime, which is going to be 1.48 over 1.33. Right, this is arc sine of all this, because I had to solve for this using some algebra, sine 20 degrees, and this gives you a value of 22.3 degrees. So this angle is 22.3 degrees. Okay, Next problem. We're given a diagram. I think it actually does not have a lot of this stuff. This was part of my solution. We're given a diagram that looks something like this, right? And then we're asked to find, we're asked to find the index of refraction of the prism. Okay, so what I had done before was I drew a normal to the diagram here, right? And then from this, we're able to tell that this is going to be 45 degrees here, because this is a 45, 45, 90 triangle. So what does that mean then? That means that this is 45 degrees, right? And then this entire angle here is going to be, this entire angle here is going to be 45 plus 15, 60 degrees is the angle that's refracted, right? That's our refracted angle. And so, because this light beam is traveling through the prism and hits what we call, this is going to be our horizontal, and this is our normal, right? This hits here at, it's 45 degrees, right? Yeah, this would be 45, this would also be 45. So, because it's hitting at an angle of 45 degrees, we can say n prism, using Snell's law, n prism sine 45 degrees is equal to n air, right, sine of 60 degrees. Because, okay, we travel here, it's 45 degrees off of the normal. It becomes refracted outside of the prism at an angle of 60 degrees from the normal. So, n prism is equal to n air, which is 1 over, well, we'll do it this way. Sine 45 is going to be square root of 2 over 2, so it's going to be 2 over square root of 2. Sine 60 is square root of 3 over 2, square root of 3 over 2. Those cancel, and then we're left with square root of 3 over 2, which, if we plug it into a calculator, gives you 1.22. That's n prism is 1.22. Next problem. So we're given that beam of light, or a ray. Sorry, I keep saying beam. The formal term is ray. So a ray of light comes here, right, and part of it is reflected, and part of it is refracted, right? The reflected light is going to make an angle with the, so like this is 40, this is going to be some angle, this angle will equal here from the law of reflection. And then it makes, this beam of light down here makes an angle with the normal, the refracted angle. And so we'll be able to, because this is 90 degrees, we'll be able to determine what this is. Okay, so let's first figure out what is theta prime. Theta prime is going to be 90 minus 40 degrees, which gives you what, 50 degrees. So then, yep, so this is 40, 90 minus 40, 50, so then this is going to be 50 degrees, right? Okay. For the next part, we use Snell's law to determine what this angle is. We were told that this is a block of ice, right? This is a block of ice, and we can just look up the index of refraction for a block of ice, and we know what it is for air. It's about 1. So we have n air sine 40 degrees equals n ice sine theta. We'll just call it theta, which is this angle here, and we want to determine what that is. So we'll just say n air is 1, and n ice is going to be, let's see, I looked it up, it's 1.309 sine 40 degrees, and this is going to be arc sine of all of this, right? This will give you the index of refraction for, no, sorry. This is going to give you the angle of refraction, and that's going to be 29.41 degrees. That's what we get. Right, so okay, we're there. So this total angle, which is what we're asked to find, total angle alpha is this angle plus this angle. And to find beta, we just take 90 minus this angle here, right? So alpha is equal to 90 minus 29.41 all degrees plus, we found earlier it was 50 degrees. Oops. 50 degrees. And that gives us a value of, what did we get? It was 110 degrees, 110.6 degrees. That's the angle alpha. Great.